Welcome to the Digital Humanities After Hours, and I'd like to present our very own Katrín Lísa Mikaelsdóttir, who is going to talk about data presentation. So the title of the talk is Drawing the Line and Knowing Where Not to. So Katrín, welcome.
Thank you. So the intention of this talk is something that might seem really basic in a way, for some people even trivial or easy to do so. But I would say that visualization as a method has often been neglected in a way or overlooked because it takes quite some effort to really do it well. And in my background as corpus linguist and statistical computing scholar, I have seen all kinds of graphs, and I think there are some things we may need to address in digital humanities to make it a little more accessible and easier and better. Because many of these graphs or visualizations are kind of hard to assess or navigate, or they even completely miss the point. So I think that's actually a pity, because it's important to get it right. Since every time we visit a website or an app or any sort of research paper that includes data visualization, the actual visual is the first thing we're likely to see and to remember. So it's kind of important that the first impression that the viewers get of the research and the main point that we'll remember is kind of on point. Why is that important? Well, because we humans are visually coded. That means no matter how important or groundbreaking or interesting our research actually is, or the tools or information that we want to present, if they are poorly visualized, they just don't have the effect we are looking for. So let me start with this. So why is that? Writing a research paper, it's made of simple building blocks that are clearly defined. We have a tier 2 standards that we have, and the same thing is true for visualizations. That means we have divisions, we have different terms or elements that need to be in a specific place, and ideally the visual answers a research question in itself, and that's the whole point of putting a visualization in sort of research projects, outputs, and so forth. Poorly, we kind of miss the point, and ideas are unfounded or really poorly explained. Now, I think there sort of is a fallacy in this, thinking that of scientific visualization, because every time we visualize something, we make decisions, and we always interpret in some way. That means we influence the understanding of the viewers, but I also, in my research, notice quite often that this applies to us as creators too. The first time we visualize something, we look at whatever the output is, and then we notice some trends that we think are there, but are they really, or have we influenced ourselves by creating some sort of visualization? Discovering trends that we otherwise didn't really know were there. So my bottom line here is, because data speaks rhetorically and not objectively, we need to put some careful thought into how we want to present the data, and that means how we visualize things and information. But the good thing is I want to point out here is that I do not really expect humanists to do it quite well. And sort of the intention of this talk is to focus on the basic principles that we can follow easily and that we should have in mind whenever we start thinking about how we want to present data. And this is why I have put the title of this talk into 3 parts. So I want to give some hands-on practical advice on what I think is good practice, then I want to give some ethical considerations, and then also talk a little bit about why I think that matters. Visualization is a broad term for using graphical presentation to show quantitative data in order to provide the viewer with the sort of core branches here that we might have. There are plenty of others like the artistic visualization or sort of immersive VR, AR, XR that are sort of important for us in digital humanities, but there are these 4 main branches that we will encounter quite frequently whenever we look at visualization. First one would be the scientific one. This is what I think most people 3-dimensional data, or anything that would be considered actual data in real world terms. That's used for the interpretation of huge corpora or data sets. So we would think of something like space models or medical 3D animations, anything that has real implications for the real world. The scientific visualization, except it represents non-physical data, and the idea is to make some abstract concepts understandable. So we transfer qualitative or categorical data, transfer them, and then we make them visible in some shape or form. Then the visual analytics is a little tricky to define. They are sort of similar to the information visualization. It's a combination of different interactive visual interfaces with computer-powered analysis. This can be data from data mining or send them together in a mostly animated fashion. And then lastly, I mentioned here the infographics. That's a composition of different data visualizations, images, illustrations, texts, and other elements. And the idea is that this should in itself present the complete story. So we will find this one really often in sort of non-academic audiences, and this is why they might be a little easier to understand than some of the other forms. So we're actually breaking this down to a really short, precise talk, because every visualization is individual and it's not really possible to say this one thing is the best way to go. So I could easily fill a whole lecture series just talking about visualization in its own, and I will barely scratch the surface here, so it kind of has to be a little basic. But I want to focus primarily on the information visualization and visual analytics, because 3 weeks ago we had already a talk about UX design, so I recommend watching that afterwards if you want to learn more on the design of interfaces, of databases, websites or apps afterwards. But principles are the same. So it doesn't matter if we have analogous, print or digital media. These are just some core principles that apply to any kind of design, and which is why I wanted to talk about this specifically for information presentation, but most of the things I will mention here are also true for any other kind of design. And goals. And that is enabling an easy understanding of different relationships, trends or patterns that are not in itself really clear, to guide us towards some interpretation of it and communicate these ideas clearly either to researchers or the general public, or a mix of both. So why does it matter? And this comes kind of early in the talk, so you would probably think that I would mention this a little later, but I figured it might be best to really mention and have this in mind first before I tell you how to do it, why it's even important to think about that. So the thing is, human brains understand images faster than written text. It makes data in a way easier to understand. It also removes language barriers. A good visualization does not necessarily need a description, or it should work in its own without any descriptions. So the idea is make the information as accessible as possible and as well formed as possible, because the idea is to ultimately make the arguments accessible inside of academia but also beyond academia. The people who usually work with large data sets, even though that's more increasing, and we might think there's more important things to focus on than having it look nice. So I think humanities researchers often deal with texts, images, places, people, or other kinds of cultural data that is not always really easy to quantify. By visualizations, for example, network graphs, that can show us how relationships exist between literary or historical sources, or we have maps that can have spatial patterns that we otherwise wouldn't know, or movements, or timelines that can show us how ideas develop over time. So when I was thinking about this, I think we humanists are actually maybe the best equipped. We like to interpret complex material, this is sort of our thing, and we communicate precisely the meaning. That's the whole point of humanities, and this is also what we need. To do great visualizations. So I'd argue that while we are not maybe the best trained in how to actually do that well or create great visualizations, I think that humanists are kind of essential in the conversation to do it well, because we make sure that visual representations are accurate, culturally informed, ethically of sciences, the natural or social sciences. I think it's our core strength and maybe also a responsibility to inform the masses, the public and other researchers how to do it well and how to criticize bad visualization. So now I've been talking quite a lot about what good presentation is, or what that we should have good presentation, but I didn't really define what I think is good, and that's actually not that easy to say. So I tried to boil it down, and I found this beautiful example, because surprisingly, if I would ask aesthetically pleasing or good to look at or something like that. But let me show you the beautiful visualizations can actually seduce you into overconfidence that is not there. So this visualization here, I hope you can see it somehow, is taken from Apple, who are usually considered the gold standard in design. And they compare their M1 chip with the latest PC laptop chip. First of all, this is all I just put up here. Everything is wrong with this graph. Kind of hard to see, but the labels and axes, they don't have any units, so we don't know what this means. They put something up that's kind of obscure on the axis, but they don't define what they really mean by that. Then there are no units, so we don't really know what that means. It's kind of baseless and meaningless. Then if we look at the scale, it looks like the latest laptop chip, which by the way is also unidentified, so we don't even know what they compare their own computer chip to. Seems to sort of stagnate, but we also don't know the scale. And I was actually testing this dotted line, which they say is 25% more performance, but it doesn't really match up with any sort of scale I could think of, so this is heavily distorted. Really? We don't know, because we have no reference points. So my takeaway from this is great marketing, but this is in itself a really poor way to present information. So when I talk about bad visualization, what I mean is it's leading to wrong conclusions. So that could be anything from incorrect data handling like we have here, not understanding what the target audience is. They sort of nail that, but this is something that can go wrong. Or they're using the wrong type of chart, using colors much better than the other one, even though there is no qualitative difference between the two. So we have plenty of things that we could do much better. So what do I think is good? And by good I mean logical flow and clarity. That means right design makes information easy to understand. Viewers should get it right away. If you look at the graph, in the best case you don't even notice that someone has spent hours really designing that it looks the way it does. So the main point of the visualization should always be obvious visualization, that is correct, clear, concise, consistent and compelling, meaning that we want accurate data to work with, represented without distorting and honest labeling. Then we want it to be efficient, so it only contains the purposeful elements and nothing superfluous that we don't exactly need in a chart. Then it should be simple enough to be understood immediately. It should have uniform encoding, so you sort of understand what's going on, and the same elements have the same meaning in all of the visualizations. And lastly, yes, should look nice enough that it emphasizes the main information and that you actually want to explore the visualization of the information that we have. So, getting a little more technical yet. How do we make effective visualizations? And I will not really exactly tell you what to do with your data. This is something you need to figure out for yourself. But there are some general steps you can take towards the right form of designing information presentation. First of all, you should have clean data before you start working on that. because data accuracy is the most important thing, or at least it goes without saying that academic honesty should be the most important thing. We do not want to mislead, we do not want to sell our products, we do research here. Because the visuals, I think, are only as good as the data that's behind it. So make sure you have structured and clean data ready before you visualize, and that the data you represent is correct. So I will not exactly tell you how to do that. I have written extensive guides in 2 languages that you can access on our website. Just so you know it's there, I will skip this part for now. So when you start about your information presentation and how you want to visualize that, the first step should be, in if not hundreds of different forms or shapes you could choose from. I just put some of them here, but there's plenty more base types that you can choose from. And there has been some discussion whether the current forms are accurately or adequately represent or are sort of usable for digital humanities data, or if you need to come up with new forms. And I'd argue we don't necessarily need to do that, because most of them are made up from the same. Think about how we do that. This is what I will get to at the end of this talk. But when we really consider what we are dealing with here, there's just a number of different ways we can choose from. And I would say, just because you have plenty of choices does not mean that you can pick just one of these that you like. I don't know, maybe this one here. Think, yeah, that looks kind of cool. Pick it and call it a day. This is not how this works. To know how I actually find the type of chart, you need to ask the right questions. And that is why, what, who, and where. So first, to take away what's my main message or point, because the storytelling will guide you through the whole process. Then next up, we have what type of data do we have to support the purpose, because that really determines your ways of including elements or what type of graph you should take. Because we can have numerical data. Then who are we making this for? Because specialists need something else than the general public or sort of non-specialists that are interested in the topic. So we really need to have in mind what is the best sort of base form that we can start with that the average user understands. So depending on who is reading or viewing a visualization, we will choose a different chart type, level of detail. I think this is not often mentioned in guides, but is equally important, is where do we actually want to publish this, because it limits our choices or can limit our choices or open up possibilities that we didn't have. For example, in print publications, we almost certainly have constraints due to formatting or colors or anything of that sort, while in websites we can even think about making the graphs interactive, which we have. This is what I want you to keep in mind before you start setting out thinking about how to make it look pretty, make it functional, and really think about the message that you want to the people to take away. Now, not all of these graphs are good for everything, applicable for everything. So we start by thinking about what do we want to show, what do we want to visualize, how are the data interacting with one another. So there are several different categories. I just split them up into 7, but there might be different ways to categorize them. And you start by thinking about, okay, do I have some sort of correlations, developments over time? And some of these base forms will already fall away, because not all of them are good at the same thing. That doesn't necessarily mean that all of them are good or bad in a sense, but really what is the main thing, what's the best way to present your data. And I've seen quite often people resorting to pie charts for some reason, especially if you want to show development over time. This is not the best idea. So really just sit down and think, what is it that I want to show? Get it look a little nicer. But that's not the only thing we need to keep in mind, because not all of these different chart types are equally effective. And this is sort of a scale that Katrín and Mikael developed in the 80s, the effectiveness scale of different sorts of visual elements. I just put some examples here. There are more just to represent what this means. But the important thing is anything that is voluminous or three-dimensional is kind of hard to grasp for human beings. So we might think, cool, a 3D density plot looks really nice, but it's also kind of abstract and really hard to grasp. So this might not be anything that is abstract bubbles, for example, because we have no relation. What that actually means, how do these bubbles relate to one another? This is especially true if the bubbles are used sort of to represent countries or anything else. So we have more abstract form of something more concrete, to which I would say, why not use a map instead, for example? And the same goes with anything here with the donut and pie charts. And one of the reasons why they are sort of not ideal is because you don't really see the difference between those different parts here. Are they the same size or are they not? It's kind of hard to grasp. So at the end of the day, effective graph to choose from. Maybe not the prettiest to look at, but it is, in terms of effectiveness, in most cases really sufficient to well design a bar chart. If we don't need to communicate or we want to communicate the most accurate data and it's more the whole general development or essence of it, it's also fine to use huge heat maps or use pie charts. It's really all boils down to the purpose of the visualization. So I would suggest to find a balance between accuracy and the data literacy of the audience. Now, moving on to basics of effective design. I will go through this rather quickly. Not against them. How do we do that? Well, we help your brain process information effectively and avoid confusion by lessen the cognitive load. So we make sure that grouped elements are actually grouped together, also belonging together, having the same properties, and the same goes for repetition and similarity. The more elements you're using that are different but have sort of the same value, that can be really confusing to keep track of. So just stick to something and make sure that in every single visualization that belongs to the same topic, the same shapes and colors and patterns repeat themselves, so they have the same meaning. Same goes for composition. In Western-centric countries or cultures, usually the top left is the point where people look and then just guide them through in a natural way of progression. It's just easier on the eye, so we just help process the information easily. Then scales. I would suggest to put the right information on the right axis. That means that we have course on the x-axis, effect on y, and timelines should go straight and horizontally. I have seen everything. That's kind of hard to process, so just stick to the basic forms. We always tend to think we need to invent the wheel, but we actually don't really need to do that. So this one I found actually kind of evil. That's the gun that's in Florida map, where we can see that the axis is inverted. So it looks like after the statute ground law was introduced, that the cases of homicides dropped, but it's actually not the case. And even if you know that this is not the case, it's really hard for the eye to process. And I tried turning this upside down and it was still really hard to process. So just to keep in mind that you can absolutely line scales or give a misleading sense of difference or similarity where there is none. Same goes for shapes. We should use shapes as categorical markers, but they can and should not be used randomly. Because shapes in itself have meaning. And I put this example here of Kiki and Booba, which are meaningless words, but most people have an association that despite association with certain shapes that we should keep in mind when we visualize cultural data, that however we shape things might also have cultural implications. And I will get to this at the end, that this can actually be dangerous if we don't do this ethically responsibly. Then if we use too many shapes and colors, this gets really hard to read, so only introduce new elements if you're sure that they make sense, because at some point it gets too cluttered and we don't understand any of the different meanings. So overdoing it is really, which is also a topic we could talk about endlessly. So I will straightly get to the point that colors should be used for emphasis, to categorize, differentiate, use them consistently, and also you do not need to introduce new colors constantly. Just use them if you know there's something you really need to highlight. They should not distract, they should not be used as distortion, and this is one of the most effective manipulation techniques that we can have, because this is the famous dress that people always see differently, and this just goes to show that we perceive colors differently depending on the colors that are surrounding. They interact with one another. And the same goes for this one here, that we just think is moving, and that is because the contrast between the colors is so high that they sort of start to vibrate with one another, and you would assume that there is some movement where there actually is none. Then there's 3 different ways to color visualizations, which I will go over just really briefly. First one is the sequential colors, meaning that we have a gradient, but it's in a progressive way into one direction, meaning that usually the low values should be lighter, the high values should be darker, and you use it if we know we have a progressive data scale that goes from low to high values, like temperatures or something like that. Here's also the danger that we can distort with that. So this is the 7-day incidence of where it would look like within 1 month suddenly everyone is infected, but this is because they actually changed the scale of the heat map and introduced another level. So suddenly it looks like there's much more infections going on. This is just because they shifted the scale of the heat map. And what I also found super confusing looking up is the aurora forecast of the Icelandic Met Office, because it would assume that white means that there's clouds, and the green one is free, because green is the color for auroras usually in Iceland. But it is the other way around, because they actually follow the principle of low should be lighter and dark should be higher. Then diverging color scale is more or less the same as the sequential colors, except it goes in 2 directions. And that means if you have a clear middle point and it goes in 2 directions, then you can use this scale. This is so you can highlight the extremes, not the middle. But it shouldn't be used for other things. Then this is what we work with the most probably. That is the categorical colors, meaning that to the different colors, but there is no implication of transition or progression between the different elements. So we use this if we distinguish between mostly non-numerical data. But here, of course, is the danger that hues should be distinct enough that you can see the differences. It's also recommended that you do not use more than 5 to 8 colors before they start bleeding together in sequential colors, even though this may look nice. But then this really bleeds together and it's hard to see what line means what. The good thing is you don't need to make palettes yourself. There are different digital tools already available, giving you different color schemes for different numbers of data classes, sometimes even up to 12. You can even check for color blindness and see what this looks like on a map. So the important thing when we use digital humanities colors data is mostly that these are not numerical data that we transpond or interpret as numerical data, which means they don't have an intrinsic value, which means that the color choices we assign to them can be dangerous, and we need to think about that. Because, like I said, they always respond and what the symbolism behind each color is. So before we just slap on any color we like, on whatever category we like, we should really think about the message that we want to give before we use and assign some sort of moral judgment that is not there. This can be dangerous if you work with people and assign, for example, skin color or gendered colors or anything like this. This will really heavily imply judgment, so really be careful when you color like that. Then something important, color in a way in information design, and that is because you can emphasize or de-emphasize by sort of filtering out everything you don't want to show, and you can let this one color speak for itself and highlight for itself. So don't underestimate that you can actually remove color to convey a better message. Whenever we do that, we need to think about people who can't. As I said, there are different ways to check that online if your colors are actually accessible or not. But what I would also recommend is adding texture to your graphs, meaning that you can still distinguish between the different graphs even though they have the same base color. You can also do this in addition to colors, just to be sure that really the message gets across. Same, I don't want to go here into details, is that usually sans serif is considered more legible on screen than serif fonts. So after all of this long and exhaustive talk about how to do it, like literally, we in the humanities should talk about where we draw the line, not just how we draw the line. And that means we always need to provide context. We need to consider that there are less data literate people, and this is most of the general public. They are non-expert viewers, and we can help them by adding some sort of visual anchors so they can have easier time to compare the different data points or reference lines. We could also think about tool streams within the visualization to give more context to the people actually making sense of your visualization. Then, whenever we interpret data, we have different levels of certainty, and these can and should be indicated on the kind of data that you have. Error bars and confidence intervals are usually used for really solid numerical data, but for the humanities it might make sense to think about, if you're not really sure, we might add some fuzziness or opacity to the visualizations to indicate how sure we actually are. Is not the absolute truth as if we know historical data. Then an important thing to have in mind is humanistic honesty and humility in data analysis. And this is one of the main points I want to make in this presentation. As digital humanists, it's our responsibility to keep that humanistic honesty and keep the human in the humanities. This also goes for data interpretation and visualization, meaning that there is always the danger that we include or exclude in the data. And what we then we need to ask ourselves, do we erase a group of people from the whole narrative? Or do we frame them in some way? Do we enforce stereotypes or biases? And all of the technical things I talk about can really help shape the story that we are telling here. Bridge gave an excellent talk about feminist DH, where we spoke about some of these issues that we need to be aware of. Who is collecting the data, who is telling the story, and for whom is the data that we are collecting. So I also recommend you watch that later. So, wrapping this up slowly, how, where, and why do we draw the line? Meaning, why does it all matter? And I try to sum it up a little bit here in two different sets of rule of thumbs that I think are quite important. One is for the craft, the more literal way of drawing the line, and one for the ethical ways of interpreting, knowing where we do not draw the line. So here again, I want to reiterate the 5 C's. Just to make sure that every element has a purpose, that is clear, that we do not need to interpret the data that we have, that we are consistent in the way, and that it's nice to look at so we know what we're doing has a purpose, and that everybody can easily understand the main message and the main point we want to make. But also something that we humanists sort of excel in is we don't have any, that we always make it clear that this is an interpretation of sometimes historical data, sometimes complex cultural data, and that we always want to tell stories about actual human beings at the end of the day. So behind every single visualizations are people, are stories, and the way we visualize them tells their story in a way that we interpret or we want to manipulate them into thinking. So even if it's unintentional, we always erase some part of the story, and I would even go so far as to say that if our visualizations risk harm or biases or enforces these stereotypes, then maybe the best thing to do is not to tell the story in the visualization, but find some other way or add more to it. Before I finish, I just want to mention a few things, few resources that I found quite useful and that can be useful in finding more tailored projects. For example, here the DataViz and the From Data to Viz projects. These give you guidelines on how to find the right type for your visualization. Same goes with the data wrapper. They have a lot of resources on all kinds of visualization. Then there is some recommended reading, brief overview of things that are useful, but there's plenty out there. And lastly, I want to close with by saying exactly this. Everything comes together. We need to know how we do it, how we do the craft, where we draw the line, and sometimes where we don't do it. And lastly, we assume a discussion of how to visualize things well.